Well, how are you?
Good. How are you?
Good. Yeah, good.
Good.
Okay, today we will cover chapter 15. It's about scheduling. Okay, scheduling. First, a company has mission, goal, strategy, long-term strategy, mid-term, and short-term. And then based on strategies, plan, production plan, service plan, whatever. Then scheduling, make it more detailed, the plan. So scheduling is assigning specific tasks, jobs, and work for equipment, facilities, and human resources in accordance with a timed planning horizon. So it's like next month is production plan, like 1,000. Then assign when, and then how many, and who will do, which machine will do. So assigning tasks to more detail. So providing detailed instruction, converting the production plan to day-to-day directive for workers, maybe a machine, equipment, and so on. Objectives of scheduling, meet due date. If we know due date, then to meet that due date, we schedule, and then try to minimize lead time by better scheduling. And setup time, minimize cost too. And then try to minimize inventory, working inventory, and maybe finished goods inventory too. And then maximize machine utilization. So with the better scheduling, we can do something, minimize something, and then maximize something like that. And infinite loading and finite loading. If we have a capacity line like this, then regardless of the capacity, just schedule. But finite loading usually under the capacity. And forward scheduling and backward scheduling. Forward scheduling, scheduling each operation when system takes an order. The system work, start work when custom order come. That is make to order system. So this one is make to order system. Make to order system. If there are multiple tasks in a system, then customer order from customer receive, then the make to order system, this one doesn't have the final product for the customer. So ask part, and so on. Then ask a supplier. So from supplier, this system doesn't know when the partner available. Then this supplier say, 2 days later you will get. Then this one know when it comes. So this one knows that time. So schedule this one and schedule this one, schedule this one, schedule this one, then send to customer. So scheduling order from upstream to downstream. So usually order flow from up to down. So the same way, like from up to downstream. So this scheduling is forward scheduling from up to down. So make to order system use forward scheduling. So product are known and product demand is unknown, because this system starts work after customer order receive. And next one is backward scheduling. Backward scheduling, production activities are scheduled by their due date. So this system for make to stock system. So by forecasting, so they know future demand, so just make. So the same. Activities or jobs, tests, they know due date. So to meet this due date, if this one take 10 days, so this one start 10 days earlier than due date. So this one knows the schedule. So schedule this one first, and second, third, and fourth. So from downstream to upstream, the scheduling order is backward. So backward scheduling. And then MRP system, we will talk about MRP system later. So like a traditional system or make to order system is JIT system. So JIT system use make to order system and then forward scheduling. Traditional system such as MRP system use make to order system and use backward scheduling. Okay, next. And job sequencing, scheduling. Schedule, assign among multiple tasks, which one first, which one next, and so on like that. Then we can use many methods or rules. First come, first service or served. This one, generally we use this one many cases. You know, I like to play golf. So nowadays I use golfnow.com or the golf course own website reserved to tea time. But when I was in New York, Long Island, like 25 years ago, I don't know, they still use this first come, first serve rule. At that time, most golf course in Long Island area, they used this FCFS rule. We couldn't reserve tea time earlier. So we just go and then if most of the golf course in Long Island has something sign outside, then somewhere looks like a clock type, then the arm 1 hour, 30 minutes like that. Then that means we shouldn't wait like 1 hour, 30 minutes, something like that. So look at the sign, then oh, wait too long. So next we try next the exit, next golf course and so like that. So many cases without a reservation system, they use this FCFS rule and SOT rule, shortest operating time among multiple tests. Take the shortest operation time or shortest task time, job first and then next and so on. And STR rule, select time remaining. Select time means time remaining before due date minus remaining processing time. If due date is 10 days later and then task time is 5 days, then remaining time is 5 days. That is select time. So among multiple tasks, shortest select time, job first and second and so on. And STL divided by OP, that is operation time. Operation, how many, the number of operations. So select time of the job and divide by the number of remaining. By this one, shortest, first and second and third. And due date, shorter due date, shortest due date, first and second and third. And critical ratio, that is due date minus current date. This is how many days left until the due date divided by the number of worked days remaining, kind of operation time. So by this one, shortest first and second and next. And then last come, serve first serve. Random, this one, usually we don't use this one. And then random, just take randomly and then give service or whatever. Example here, job A, B, C, D, E. They come A first and B second, C third, and so on. And then processing time, due date, remaining time. Then if we use FCF as a rule, so take A first, because this one come first and the second. So the sequencing is this by they come. The processing time 34261. So flow time. This one started from 0 and use 3 days. So this one needs 3 days. And then assume they come together. Then 3 days until this one finish. And plus this one's processing time. So total flow time of this one is 7 days, 9 days, and so on. So to complete all 5 jobs, total flow time is 50 days. And the mean flow time is divided by 5 because 5 jobs. So mean flow time is 10 days. And the on-time job is only one. A, meet the due date. Others, miss due date, late due date. And then lateness. Job A, meet the due date, so 0 lateness. Due date is 6, but this one finish in 7th day, so 1 day late and 2 days late and so on. So total lateness divided by the number of job equals average lateness. And SOT rule, if we use SOT rule, shortest processing time or operation time, task time first, and second, third, and so on. So sequencing is ECABD. Then total flow time 36, mean flow time 7.2. On-time job E and C. This one meet the due date, and then this one meet due date, but this one day late, 4 days late, and 7 days late. So total lateness, and then divided by 5, average lateness is 2.5. So using such rules, then get total flow time and average lateness and so on. Then compare those rules. Then SOT rule is shortest, fastest sequencing rule. So if we can use this SOT rule in real time, real world, this one work. But sometimes it's harder to adopt this rule, use this rule. But if we can, then this one always fastest sequencing rule. Otherwise, maybe due date rule is shortest. And sequencing n jobs on 2 machines. It's like 2 stages, multi-stages. Certain job need 2 machines. That case, to finish all jobs in minimum time, we can use this rule, Johnson's rule, to minimize the flow time, total flow time. So first step 1 is list the operation time for each job on both machines like this. So job A need 3 time unit on machine 1, 2 time unit on machine 2, B68567 First list times like this, and then select the shortest operation time. And then if the shortest time is for the first machine, then do the job first. If it is for the second machine, do the job last, and then repeat step 2 and 3. So first step, among all processing times, shortest. This one is shortest. Job A. Job A assign, but this one, the shortest time for the machine 2. So place job A last. And then cross out, because this one assigned, cross out, and then among remaining times, next shortest is this one. So do the job D second last. Place job D second last. And then cross out this job. And then among remaining times, 6586, this one is shortest. So job C, and then this time is for machine 1. So do the job first. So place job C first. And then the remaining job is B. It doesn't matter if it is first or second. Anyway, place job B there. So job sequencing is C, B, D, A, and then job C goes in machine 1, and then finish, then move to machine 2, then take job B, and then move to machine 2, then take job D, move to machine 2, and then take job A, and then move to machine 2. So total flow time is 25. And this total flow time, when schedule CBDA, that is shortest total flow time. This is Johnson's rule. By the way, you will have assignment from this chapter, this one. 2 questions. One question is about this Johnson's rule. This one is not very hard. Just follow that steps. Okay, question. Okay, good. Next one, personnel scheduling in services. It's like a restaurant or bar. Then they use like a service system. They need personnel workers. Then if customer size or demand is stable every day, then they need the same number of workers. But sometimes demand different. Monday, Wednesday, Tuesday, not many customers demand, but Friday, Saturday night have a party, many customers come, then need more workers. So if the number of workers need different number of workers need day by day, then how can we schedule workers? That is personnel scheduling in services. To find the schedule that minimize the number of 5-day workers who with 2 consecutive days off. So the condition is during 7 days a week, work 5 days and then 2 days off. Step 1, assign the first worker to all of the days that requires stepping. Circle the 2 consecutive days with the lowest number, such required number. Then step 2, for worker 2, subtract 1 from each of the day not circled with the positive numbers and enter this in the worker 2 row. Example, if a certain store, restaurant, or something, they need the workers, then on Monday, This store need 4 workers. And Tuesday, 3 workers. Wednesday, 4 workers. Thursday, 2 workers, 3 workers, 1 worker, and 2 workers. Then it says, assign the first worker to all of the days. That means just copy the required number for worker 1. And then the condition is work 5 days and then off 2 days, consecutive days. So circle two consecutive days, and then this one add and then 7. Circle 2 consecutive days and add and 7. 6, 5, 4, 3. So among these kind of combinations, this one is smallest. So circle these 2 days. These 2 days. That means worker 1 will be assigned Monday, Tuesday, Wednesday, Thursday, and Friday, not Saturday and Sunday. So, because worker 1 assigned those days, so -1 from here, then it will be 3, -1 will be 2, -1, and it will be 3, and 1, 2. Because Saturday and Sunday, worker 1 will not work, so remain the same number. And then the same. Change it like this, from 4 to 3, 3 to 2, 4 to 3, 2 to 1, 3 to 2, and remain the same because they circled. And then circle again, 3, 2, 5, 2, 3, 5, 3, 1, 4, 1, 2, 3, 2, 1, 3, 1, 2, 3. So there are 3 ties, 1, 2, 2, 1, 1, 2. Maybe we can assign arbitrarily or ask worker 2, then worker 2 said, I will not work Friday and Saturday. Okay, so circle there, and then again, -1, -1, -1, -1, -1, remain the same number. And then circle again, and then here, this one, 0, 2, and 1, 1, tie, and ask worker 3. And then worker 3 said, I will not work on Saturday and Sunday. Okay, assign, and so on. So, worker 1 will work Monday through Friday. Worker 2, Monday through Thursday and Sunday. Worker 3 will work Monday, Tuesday, Wednesday. This one not available, and Friday, and so on. So assign like this. And then count. This one on Monday, 4 workers are required. 1, 2, 3, 4. 3 workers required. 1, 2, 3. and 1, 2, 3, 4, 1, 2, 1, 2, 3, and 1, 2, and so on. So this one is a personnel scheduling method. And next one, scheduling a set number of jobs on the same number of machines. If there are multiple works and then assigned to the same number of machine or personnel, we can use this method, assignment method. A special case of the transportation method of linear programming. Later, we will cover linear programming and transportation, part of the transportation method. In detail, at that time, I will talk about this linear programming more. Anyway, assignment method is one of the linear programming methods. There are n things to be distributed to n destination. It should be the same number of workers, same number of the same number of machine or jobs and so on. Each thing must be assigned to one and only one destination. So match 1 to 1. By the way, if it is different number, like 5 workers and then only 4 machine or 4 jobs, then to make the same number, we add 1 dummy machine or dummy worker and so on. So always match the same number, 5, 5, 4, 4, and so on. And then use only one criterion, because this linear programming is one single objective method. So use among those like minimize cost, maximize profit, minimize time, and so on. So using only one criterion. Example, there are 5 machines and jobs. There are 5 and 5, same number. And then if job 1 is done by machine A, the cost is $5, $6, $4, and so on, their cost. So this one is a minimize problem using a minimize cost criterion. Step 1, subtract the smallest number in each row from itself and all other numbers in the same row. So first row, smallest is this one. So subtract the smallest from each number on the same row. So 5 minus 3 is 2, 3, 1, 5, and 0. Change it like this. Then second row, 4 is smallest. So subtract the smallest number from each number on the same row. So 2, 0, 5, 3, and 1. And third row, 2 is smallest. Next row, 2 is the smallest. And next to 3. So subtract 2, 2, 3 from the same row and change it like this. And then column, from a column, smallest. On this column, 0 is smallest, so it doesn't matter, it doesn't matter, it doesn't matter. But here, column for motion D, smallest is this one. So subtract the smallest from number on the same column. So 3, 2, 1, 1, 0. Then determine if the minimum number of lines required to cover each 0 is equal to n. Minimum number of lines required to cover each 0. If the minimum number is the same as n, this case n is 5, 1, 2, 3, 4, 5. So the minimum number of line to cover all zeros, then 5, then we can get optimal solution. But if not, then we need another step. So try, when we cover 0, we can use vertical line and horizontal line. When we cover zeros, column or row, 2 or more zeros, cover that column or row first. So on this column, there are 2, so cover this column by a line, and then here there are 2, so cover this row using a line, and then remaining 0 here and there, it doesn't matter, using horizontal line or vertical line, cover. So cover all 0 here and here and here using 4 lines. The minimum number of lines to cover all zeros, 4, but n is 5. So we need another step. Another step is subtract the smallest number not covered by line. Not covered by line, they are in blue. Among them, smallest is this one or this one, 1. So subtract this smallest number from numbers not covered by line. So 2 minus 1 is 1, 1, 4, 0, 4, 1, 2, 1, 0. And then try again using lines to cover all 0. The same rule. If there are 2 or more 0, cover that column or row first. So cover this one, cover this one, cover this one, and then remaining here and here. It doesn't matter, using horizontal line or vertical line. So cover all zeros using 5 lines. The minimum number of lines to cover all 0 is 5. And then n is 5, the same number. So we can get optimal solution. So zeros, now where the place where 0, like this, then we can assign using that. So 1 has 0 on C and E. Job 2 on B. Job 3 on C. And job 4 on B and D. And 5 on A and D. So when we assign the rule 1 to 1, and then job 1 can be assigned C and E multiple. This one only 1, this one only 1. So assign only one available job or machine first. So assign this one to D2, and this one not available. Then this one becomes only one available, assign, and this one not available. Assign this one, and then assign this single available, and then this one not available, assign. So assign 1 to E, to 2 B, and 3 to C, 4 to D, and 5 to A. And then cost from the original table. If job 1 is assigned to E, then cost is $3. 2 to B, $4. 3 to C, $2. 4 to D, $5. 5 to A, $3. So total cost will be $17. It's very complicated, right? Can you do it? Elisa, you can do it? Yeah, you can do it, but it's complicated. You know, assignment 15, chapter 15. I will show you. So using Johnson's rule and using assignment method to find the total cost, like this. Okay, but I will, maybe it is the simple way, but to someone it's not complicated, but hard way. I will show you another way to solve this assignment method. Take a 5-minute break, about 7 minutes. I will be back 6:50, 6 minutes later. Okay, see you in 6 minutes. Okay, sounds good. I'm back. Are you there? Okay. Okay, that assignment method, you can use like hand solving method, and then you can use this Excel. So first you need a table, the list, the cost, the original table. Where are you? Okay. So based on this table, 5 machines and jobs and each cost list. So first the cost table, and then assignment table, same number, is blank. And this one is on Moodle. This example file is on Moodle. So if you can download this file, then if you can do it together. So if you have only one monitor, then you can divide your monitor two parts, and then the other part watch my instruction. So one side this file, and one side maybe watching my instruction. Okay, I don't need a divide. Okay, are you ready? So you need a cost table and then assignment table like this. And then this table, you don't have to touch. I made this one. Then we will use solver add-in. In data menu, there is no solver. If you don't have this solver add-in, then you should add in this one. Click File, and then Options. Because that solver is add-in, one of add-ins, so click Add-in, then it will change like this, and then click Go. Then this one is the default, the basic Excel add-in. So you should have this one, but it may not checked. So this one is not checked. Unchecked, then you cannot see solver on this menu. But if you check this one and then click OK, then you can see solver. Okay. Before you use a solver, you need some work. Assignment method, the one of the criteria of the condition of the assignment method, assign only one-to-one. That means if machine is assigned to job 1, and then other machines cannot be assigned. So this row should be 1. Should be 1, should be 1. Some of this assign should be 1, 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 and so on. So click this cell, and then we need this function type equal. Before you type equal, on this little window, show the cell location G and 11, but after type equal sign, it change to function. So we need sum of, so you can type sum of, or you can find the function from a drop-down menu. So if there is, then click the sum. Then this one asks you range. So sum of, or if I type equals sum, then you can double click this, whatever you need. Then it change, and then open parentheses, and then we need area. We can specify the input range by click first cell, then don't release the button, just drag wherever you want to, and then release, and then specify that range, and then you can just type enter or close parentheses and then enter. That it change like this, because this time there is no number. And then we need the next row, the same, equal sum, and then specify the row, enter. You can do it one by one, or after you done first row, then just place your cursor right bottom corner, then it change like a plus sign. This one also plus sign, but it's a thick one. And then I will make it bigger. Change narrow in plus sign like this. Then click, and then drag down, and then copy it. And then click, and then look at this, sum B11 to F11. Next one, B11, 12 to 12. So cell change it automatically. And the next column, the same, your sum of, double click, and then specify the range, enter. And then copy. So assignment table, we finish. And then need total cost cell. This one is like, I will show. Total cost is like this. We assign one to E, two to B, and so on. So that means 1 to E. If we run that the Excel server, then assigned, then indicate like 1, 1, and so on. So 1 times $3, 1 times $4, and so on. So that is total cost. So that one is here. So if job 1 is assigned here, then others 0, 1 times this one. Plus, if 2 is assigned B, then 1 here, others 0. So 1 times 4, and so on. So this one equals, the function is sum product. Sum product. So product E1 times 3 plus B here 1 times 4, and so on. So sum of product. So function is sum product, SUM, sum product. So sum of product, then specify this range, and then comma, times this range, and then close parentheses. Say again, this sum product means product of this one times this one, and then add. So specify this range, comma, specify this range, and then enter. This time, they are not assigned yet. So this one is 0 because they are 0 now. And then click solver, and then give some condition. Set objective, that is this one. So we need this to find this total cost. We run this solver. So when cursor is blink here, then click this cell. So we need this total cost, and then this problem is minimize problem. If they are kind of profit, then we need click this maximize. But this time, this one is a minimize problem. And then by changing variable cells, we need here assignment table. So this one is fixed. Change this one. So changing variable cells, they are. So click this box, and then when it's blink, then specify this area. And then we need constraint, condition, That means this assignment rule match 1 to 1. So this rows, sum of this row is 1. Sum of this row should be 1, 1, and this column 1, and so on. So add, click add condition. This cell should be 1. And OK. You can do 1 by 1, but easy way is, I will delete this one. The easy way is add again all of them. This one, this one, this one, this one, all of them will be 1. And then, OK. So this cell, this cell, this cell, this cell, this cell, all cells equals to 1. And then add another. This cell, this cell, this cell, this cell, this cell should be 1. So specify that range, then equal to 1. Then OK. And then this one is default checked. Make unconstrained variable non-zero. Because they should assigned 1 to 1. So it should be 1, it should be 1, it should be 1, it should be 1, not 0. And then not negative. So it doesn't matter, check, uncheck this time. It will not affect, but usually we need this one checked. But anyway, this one is checked default. And then we need simplex LP method to solve this problem. So linear programming usually use this simplex method. Then ready to click solve. Okay, all conditions are good, and then click solve. Then this one, make sure if this one looks okay. Looks okay because now this one 1 1 1 1 1 1 1 1 and so on. And then we will keep this solution. So okay. Okay, compare with using hand solution. Change screen. A to E, 1 to E, 2 to B, 3 to C, D, A, and then cost total is 17. So E, B, C, D, A. E, B, C, D, A, and then total cost is 17. The same result. What do you think? Can you do it? Doable? Okay, I will make a little bit easy for your doing assignment. So I made wedge table for the assignment question number 2. So I made a wedge table like this. So you need to specify process here, sum of. They're using sum product function. And also, I made instruction PowerPoint slide for doing the assignment. Like this. And next page, what you need. So it doesn't matter using a hand method or using this Excel solver. So if we use this Excel solver to do the assignment, then hand in Excel file and Word file. Due is next Tuesday. For this class, I will try to use more Excel or Excel add-ins to solve the quantitative part. So I will show you more using Excel instead of using a hand calculation. So next class I will show you and then let you experience more like Excel computer software to solve operations management quantitative problems. Any question? Today also a short class. I heard Dr. Dumdum used all the total, the whole class times, but I used not like that. Hopefully you like this short class. Okay, if you don't have a question or suggestion or complaint, then that's all. And see you next Wednesday in class. Some of you see you in class, others online. Okay, that's all.
Thank you, Dr. Kim.
Thank you.
Dr. D. Kim.
Have a good one, Dr. Kim.
Thank you, Dr. Kim.
Thank you. Good night.
Good night.
Dr. Kim, I have a question.
Okay.
The problem that we just solved right now, you said you could either do it using the Excel add-in, that's the solver, or we could do it.
It doesn't matter. It doesn't matter. Yeah.
So if I'm gonna do it using the add-in, I do not need to submit the Word file, right? Only Excel.
What file you need now? Because the first question need a hand. So if you use an Excel, then you need an Excel file, and then that is the second question. And then first question using hand. So you need 2 files.
So we need both the Word and Excel.
Okay. If you use only hand, then Word file only, but if you use Excel, then you upload the Excel file too.
Okay.
Okay.
So when you were showing how to do the Excel file using the solver add-in, I was doing it with you. But for some reason, I selected the values exactly like you did. But I get, when I go to the
Different number.
results, what's that?
Mhm.
It tells me the solver could not find a feasible solution.
Maybe you type in using the like a sum, then the constraint part. Maybe
Oh, I
that is
use the
wrong.
exact constraints. I could share my screen and show you if you want.
Okay, I will make it. Let's just share. Okay, you can share your screen now. Let me see.
Can you see it?
Now, yeah, I can see.
So,
Click cancel,
yeah.
and then move cursor to. You know, don't touch anything. Just close that. Close that. And then now, on the just the beneath of the menu, go up, up. No, don't click. Click total cost. Click total cost 0. Right. Okay. And then up there, in the little window, some product B32 F7. B32 F7, okay, and then comma B11 to F15. That is good. Okay, and then click G11 raw total. Yeah. Let me see. B11 to F11. That is good. And then next one. Okay, good. And then column total. B11 to B15, that is good. And others are good. Okay, and then click solver. Let's see. That is not, should be there. Okay. And then changing variable. B3, no, that is wrong. Changing variable.
That should be this part, right?
Yes. B11 to F11, and then
F15.
B16 to F16, B16, that is wrong. So click that one and delete. And that one too. And add, and then cell G11. G11. And then specify until 15. Okay, and then equal 1, add, and then another cell. Click B16, and then specify to E. Okay, then equal 1, and okay. And then check simple X and minimum, and then okay, solve.
Oh, I found it.
Yeah.
So that says found a
Yeah.
solution. All constraints or optimality conditions are satisfied.
Yeah. And the total cost is 17. That is the right answer.
Okay.
So I think you wrong specification of the constraint.
I think
That
so.
was the problem. So it's easy, right?
Yeah, it is.
And fun.
Yep. And for the Word file, this
Mhm.
has to be done manually, right?
Yes.
Okay. Sounds good.
Okay, good.
Okay. Thank you so much, Dr. Kim.
No problem, anytime. Okay, see you
See you next Monday.
Monday. Mhm.
All right. Have a good night. Bye-bye.
Good night.